Okay, welcome to day one of Unit 3. We're going to talk about lines and angles and slopes of parallel and perpendicular lines. Some keywords today, we're going to use the word skew, parallel, perpendicular. We're going to be able to identify parallel and perpendicular lines, and we're going to be able to determine whether or not they are perpendicular, all right? So start with some reminder things that we know, things that we've been talking about. The slope of a line, that's rise over run. It's the change in y over the change in x. You can use the formula. You can use what I've showed you guys in class where you draw it, give yourself a sketch, and then just think of the difference between the two. But that's there, the slope of a line. We got to know that. So example, find the slope of the line passing through those points. You can use the formula, use the graph, use the concept, whatever you want to do. Again, just as a quick refresher, the way that I like to think of this problem is I give myself just a really quick and ugly sketch. -2, 0 is here. 3, 1 is there. So I know it's going up. Okay. The change in the y's. Okay. The change in the y's is 1. The change in the x's is 5. So I know the slope here is 1/5. Okay. No problem. Example 2. Go ahead and take a second and do that one. You can pause the video. All right, you've unpaused. Again, sometimes it's useful. -1, 2 is here. 2, 2 is here. We see that we have, yikes, we see that we have a perfectly horizontal line, and the slope of horizontal lines is 0. Okay, so m equals 0. So go ahead and pause the video here. Find the slope of each set of those points. When you unpause it, I'll have the answers there. If you don't have the answers, try again. If you still aren't getting them, raise your hand or ask a question or make note of it, and we'll look at them together in class. So go ahead and pause the video here and get some answers for slope. Pause the video now. So I got 3, -1/2, undefined, and 0. You'll notice on undefined and 0, if the x values are the same, that's going to be a vertical line. Okay, so that's going to be undefined. If the y values are the same, that's going to be a horizontal line, and the slope there is 0. All right, moving on. Pairs of lines. Pairs of lines can relate to each other in 4 different ways. Okay, you need to fill in these blanks. The lines can intersect. Okay, lines can be parallel. Lines can be perpendicular. Okay, or lines can be skew, which is tough to draw without having a 3-dimensional shape. So we'll look at that in just a second. All right, so intersecting, parallel, perpendicular, or skew. Intersecting lines are lines that meet at a point. Okay, lines that meet at a point. Yikes, what's happening right now? And so right here we could just say that A, B, and C, D intersect at point E. So those are intersecting lines. Parallel lines are lines that are coplanar, which means they lie in the same plane. Okay. And they never intersect and have the same slope. When drawing parallel lines, you should always put arrows on them, okay, so we know that they're parallel. So the slope of this first line here, line L, okay, the slope is, if we go down, let's see, we can count here, down 2, 4, down 5, and then over how far? 5 that way, and then 5 that way, so that's down, it's negative, and 5/10 is 1/2. And here, same thing, we get down 2 over 4, but that also reduces to 1/2. So parallel lines are going to have the same slope, right? Perpendicular lines are going to have opposite reciprocal slopes, and we looked at this already, right? Like, so line P goes down 2 and then over 4, so that's -1/2. Line A goes up 2 over 1, so that's 2 over 1, which equals 2. Okay, we're not going to say 2 over 1, we label that as 2. There's a symbol for perpendicular. It's an upside down T. It looks like 2 lines that are perpendicular. All right. And real quickly, I forgot. The symbol here for parallel lines are just 2 like, they look like L's. You make them longer than your L's so we can tell the difference. But they're parallel lines. Okay, that's the symbol there. Skew lines are lines that aren't going to intersect, but they also aren't coplanar. So if we look at this box, this line AF goes forever. and this line JK goes forever. They're never going to touch each other. They're never going to intersect, but they're not parallel because they're not in the same plane, okay? Skew lines exist in three-dimensional space. Those two lines would be skew. All right, now we did some of this previously. Let's take a look. Write the equation of the original line using y equals mx plus b. So the slope here, let's first figure out the slope. We go down 3, 6. So down 6, we know it's negative 6 over 3, and we're always going to reduce. So that's negative 2. The y-intercept is right here at negative 1. So the equation is y equals negative 2x minus 1. Okay, some practice with writing our equations. A parallel line has the same slope but a different y-intercept. So just, if the slope here, same line, okay, down 3, or down 6 over 3. So the parallel line has the same exact slope, just pick any different y-intercept. You could pick 8, 7, 400, negative 1,000. Like, it doesn't matter. Plus any number. So I'll just say 5. Okay, that's an easy one. 0. Again, anything. It could be anything. Our perpendicular line has a slope that is the opposite reciprocal of the existing slope. So if the slope of this line is negative 2, then its reciprocal is 1/2. If it was negative, now it's positive, and we take 2 over 1 and we flip it. So the perpendicular line would have a slope of y equals 1/2 x, and then again, pick any number. It doesn't matter. 0, 1, 2. I'll just pick 5 again. It doesn't matter. Any number. All right, let's take a look. The figure at the right is a cube. Identify a pair of segments that are parallel. So a pair of segments that are parallel. There are lots, guys. Let's just pick one. Somebody pick one. Good, I like that answer. AD is parallel to BC. Perpendicular. How about AD and AB are perpendicular? Okay. And these are segments. Let me put my segment notation up here. And then skewed. That might be a little bit harder. AB is skew to CG. Okay. See if you can name your own set and check them with me, and I'll let you know if they're correct. Remember, if you have ordered pairs, graph whenever possible. Okay, graphing is always going to give you a good view of it. Something else that might help with tonight's work, recall from algebra, some of you guys learned Hoy-Vux. Vux is vertical lines have undefined slopes, and x equals for their equations. Hoy is horizontal, 0 slope, and y equals for their equation. So Hoy-Vux, some people remember that because it's just catchy. Who doesn't like saying Hoy-Vux? Given the lines, determine if they are parallel, perpendicular, or neither. So the big hint here is this. We have to solve for y first. So we have two different lines, okay? So let's take this first things first. 3x plus y equals 5. We have to get the y by itself. So if I add 3x to both sides, I end up with y equals 3x plus 5, okay? Then let's take the second equation, x plus 3y equals 6, and let's solve for y here. So subtract x, and I get 3y equals negative x plus 6. Then I'm going to divide both sides by 3, each term by 3, okay? And I have y equals negative 1/3 x plus 2. And then we want to look at the slopes. This is negative 3, or negative 1/3. This is positive 3. Are the slopes opposite and reciprocal? And the answer to that is yes, so these two are perpendicular. Okay? Take a look over here. If we solve for y here, we're going to add 4x to both sides. And we get y equals 4x plus 6 for that equation. For the other equation, we're going to add x to both sides. So now we have 2y equals 8x minus 10. Divide both sides by 2, and I get y equals 4x minus 5. And then again, let's look at, this is a 4, and this is a 4. So those two lines have the same slope, which means those two lines, even though they look completely different, those two lines are parallel. All right? Now, I got some practice for you. I'm not going to do these. You're going to do these, and then we'll check them together, okay? Practice for you. There, and there. Okay, 6 problems. I need you to work on those, and I'll put in some answers here in a second, and you can check and see how you did. Okay, go ahead and pause the video, do those 6 problems, and then check them. Pause the video now. All right, let me walk you through my answers real quick. I got a slope of -1 and a y-intercept of 4, so when I write that out, I don't include the 1 here. We don't need that. Again, the parallel line just has the same slope, and this y-intercept, this could be any number. The opposite reciprocal of -1 is 1, so that's how I got this. 5/4, 5/4, -4/5. Again, these numbers over here on the right could be anything. My answers here, I got 5/3 and -1, so 5/3, 5/3, and then here I got -3/5, and again, these numbers on the right could be anything. -3/2 and -3, so that's that, and then this one's 2/3, and these numbers on the right could be anything. Tricky one. M equals 0. The B is 2. So y equals 2. A horizontal line has the equation of y equals 2. A parallel line to that could be y equals and then any number. I chose 3. And a perpendicular line to that is going to be a vertical line, which is x equals any number, and I chose 4. Here, -3/2, -3/2 and 2/3. I chose not to put any number after it this time because the y-intercept could be 0. It might go through the origin, so I just left it blank, which is also correct. If you have questions on those, let me know. That's it for the notes. See ya.